All right, you guys, for the next part of this chapter, we are looking at significant figures and then looking at significant figures and calculations. Some of you guys have actually already studied this topic if you were in honors physical science. Some of you guys, this may be a new topic. This is an extremely important topic that's going to kind of carry throughout the entire year. So this one you need to get down. It's not a difficult topic, so if you didn't get it last year, it's not anything that you're behind on. We will get you caught up and make sure that you understand this. So what we have to deal with is when we're dealing in a, not a math class here, but a science class, we're looking at measurements. So we kind of have to, what we say, estimate. Let me get my pen here. We have to estimate our last digit. So there's always, when I'm trying to measure something, I've got to say, okay, well, is it exactly 12.5 centimeters or could I maybe say 12.55? And I've got to estimate that last digit. Well, because of this, we have to deal with numbers in that we call significant figures, meaning we have to record our answer correctly. We can't make it more, like what we talked about in the last section, we can't make it more precise than what went into those measurements. So we have to follow some rules. And now I could give you a whole laundry list of rules here, and you could memorize them all. But if you just remember this one Atlantic Pacific rule, you can look at any number and tell how many digits are significant in it. Now, you may hear me say significant digit or significant figure. It means the same thing. So you just have to kind of understand two rules here. If there's a decimal place present, you're going to start counting at the beginning of the number, and you're not going to start counting until you get to a number that's not a zero. And I'll explain that with some examples. So, and then if there's a decimal place absent, you start counting at the end of the number, and you don't start counting until you get to a number that is not a zero. So basically you have to figure out, okay, am I looking at a number that has a decimal or does it not have a decimal? Where does the Atlantic Pacific come in? Well, I'm a terrible artist. So what you're going to do is you're going to visualize the United States right there. So if you do that, the Atlantic Ocean is over there. The Pacific Ocean is over here on the West Coast. So what we're looking at is it present or is it absent on where we're going to count for the number? So how do we do this? If we look at a number, 2.50, well, 2.50, there's a decimal place present. And what it says up above in the rules is I would start counting at the beginning of the number. So I'm going to start counting at this end, and I'm going to count that way. So I would start at the 2. Well, that 2 is not a 0, so I would start counting, and I would keep counting until I'm done. So all three of those digits, 1, 2, 3, all three of them are significant. So I would say that this measurement has 3 significant figures. Well, what about if I've got 0.0730? Well, again, there's a decimal place present, so I start counting at the beginning of the number, but the rule says I do not start counting until I get to a number that's not a 0. So when I start at the beginning, I don't actually start counting until I get to that 7. So when I'm counting that way, I start counting at the 7, and again, once I start counting, I keep counting. So the 7, the 3, and the 0 at the end are my significant ones. So there's only 3 significant figures in this one. What about 450? Well, this time I'm on this side. Decimal place is absent. The only difference is I start at the end of the number and I start counting backwards towards the beginning of the number. So I'm going to be going that way this time. So again, I can't start counting until I get to a number that's not a 0. So I'm going to skip that 0. I'm going to start counting at the 5, and I'm going to count that direction. So the 5 and the 4 are significant in that. So there are 2 significant figures in that measurement. All right, what about 7,600? Again, decimal place is absent, so I'm going to start at the end of the number. Again, I won't count those initial zeros. I'm not going to start counting until I get to the 6. So the 6 and the 7 are significant. So there are 2 significant figures in that one. So let's practice a little bit with these. I'm going to kind of go through and just quickly go through these. If you want to pause me and just see if you've got it down, check these to make sure you can actually look at a number and tell how many significant figures. So on A, I would be using the absent rule, so I would start at the end, so that 0 is not significant, so there's 2 in that one. In letter B, it's the Pacific rule, so I start counting at the beginning, and automatically first one is not a 0, so I would start counting and keep counting, so all 4 of those are significant. On letter C, there's a decimal place present, but I would not start counting until that 5, so there's only 3 significant there. In letter D, it's absent, so I start counting at the end of the number and work backwards. The 3 is the only one that's significant, so there's 1 significant figure there. And then 7.500, there's a decimal place present. I would start counting at the 7 and keep counting. So there are 4 significant there. In letter F, it's absent. I would start at the end and count, but all of them are significant, so that one would be 3. And then now we're just giving them to you in kind of a word problem form. But again, I just have to look at that number. The zeros are not significant in the beginning, so the 1, 0, and the 5 are the significant ones. That's 3. The next one, decimal place present, but I don't start counting till the 5. Once I get to that 5, I keep counting all of those. So there are 5 that are significant on that one. And then on the last one, you don't take into account the exponent, so you're just looking at the 8.050. Well, I start counting at the 8 and keep counting, so there are 4. Now, just to go up and kind of highlight, if I've got that 300 on letter D that had 1, what if I added a decimal place there? Well, then I would start counting at the beginning of the number because there's a decimal place, and I would keep counting. So adding a decimal makes that number significant. Just kind of keep that in mind when you see that come up. All right, now what we have to be able to do, and this is kind of what you'll be doing the rest of the year. So you have to be able to use those rules and be able to record your number, or your answers to the correct number of significant figures. You're going to see this on a lot of problems this year, especially on the Missouri Baptist test. You do have to be able to record your answer correctly. So there's a separate rule, one for multiplying and dividing, and then one for adding and subtracting. So I'm going to go ahead and kind of talk about the rules here, but then we just have to practice with it to really get this down. So for multiplying and dividing, it says the term with the least number of significant figures. So you can't make your measurement more accurate, more precise than the numbers that went into it. So in this, I'm asking you to multiply 4.56 times 1.4. Well, 4.56 has 3 significant figures. 1.4 has 2. So I've got to record my answer to the least number, which is 2. But my calculator gives me 6.38, so I just have to be able to round it. So to review rounding rules, that 8 rounded that 3 up to a 4. So my final answer, 6.4. 2 significant figures. Same thing if you're dividing. And then if you're adding and subtracting, in this case, you have to go with up here it was the least number of significant figures. This one, you're going to be strictly looking at decimal places and recording it to your least number of decimal places. So I've got it kind of written in my example here. 12.11, that carries out 2 decimal places. 18.0 is just 1 decimal place. 1.013 is 3 decimal places. So I'm looking at how many numbers come after the decimal point. So this one was my least number. So I add everything up in my calculator like normal, and it gave me 31.123. But I need 1 decimal place. So that 2 will not round that 1 up. So my final answer is 31.1. So there's the 2 separate rules. We'll kind of work them separate, and then we'll kind of work some multi-step problems so you can kind of see how to do those. Okay, so first up is it says perform the following calculations and record your answer to the correct number of significant figures. So up above is just some easier ones. Down below is where we start getting into the multi-step ones. So on letter A, I've got to multiply. Remember, multiply is record your answer to the least number of significant figures. So go ahead and just multiply in your calculator. What does this give you? Well, I got 9.62. But I don't know if that's my correct answer because my goal here is to be able to record my answer correctly. Well, when I look at those 2 numbers, that one has the least number of significant figures, and there are 2. So I'm going to have to stop at 2 significant figures. So there would be 2 significant figures. But I always need to look at that next digit and say, do I need to round up? If it's 5 or higher, you round up. If it's not, then you don't. So to get my 2 significant figures, it would just be 9.6 for that one. On the next one, you've got 4.5, 2.86, and 3.1. So again, go ahead and add those up in your calculator. What does it give you? I got 10.46. Okay, but I don't know if that's my answer. My rule for adding is least number of decimal places. Well, that one has 1, and that one has 1. The other one has 2. So least number is going to be 1 decimal place. So there's my decimal place here. I'm going to stop here, but I need to, again, look at that next digit. That 6 is going to mean that I need to round up. So my answer here is going to be 10.5. All right, letter C, dividing. Take 4.85, divide it by 2.703. Your calculator gives you a very long number, and I'm not going to write the whole thing down, like 1.7943. 0, 2, 6, 7. It may keep going. But again, I can't record that as my answer. That is way too precise for the numbers that went into the measurement. So my rule for dividing is least number of significant figures. My top number has 3 significant figures and my bottom number has 4. So that is the least number. So I need this to be 1, 2, 3 significant figures. I need to stop there. But I do need to take a look at that next digit to tell me if I need to round up or not. And in this case, it's a 4, so I'm not going to round up, and that would be 1.79. All right, letter D, 10.005 minus 3.65. Calculator gives you 6.355. But again, I can't leave it like that because it's too precise for the measurements that went into it. This is subtracting, so I got to look at those decimal places. That one has 3. That one has 2. So I need to stop at 2 decimal places. So if this is my decimal, there would be 2 decimal places. There would be 2 decimal places, and I need to look at that next digit. That next digit tells me that I need to round up. So I need it to be 6.36. Okay, so that's just one-step problems. Now we need to look down below because you can kind of see now I'm actually asking you to do a couple of different steps. Now, what you have to understand here is when you do a couple of different steps, you have to make sure that you're rounding your answers correctly before you move on. So you've learned this in a math class, but whatever is in parentheses, you have to do first. So what I have to do is I have to do that step in parentheses in letter A first, record my answer correctly before I move on. So I'm going to multiply those numbers out of my calculator. 7.405 times 3.25 gives me 24.06625. But again, if I move on with that number, I may not end up with the correct number of significant figures because that's way too precise. If I look at the values that went into that, the 3.25 has 3 significant figures. So I need to make my number have 3 significant figures. That would be 1, 2, 3. But I need to look at that next digit, and that's telling me I need to round up. So I'm going to move on with 24.1. Well, then it's asking me to say, okay, well, you've got the 24.1. Now you need to divide that by 4.6. And what does that give you? Well, my calculator gives me 5.2. Oops, why is it not writing? Let's try to erase that. 5.23913. And again, if I hadn't fixed my 24.1, it would look like I had way too many significant figures. But in this case, the least number, because I'm dividing, is this 2 significant figures here. That one has 3. So I need to make my answer have 2 significant figures. That would be this right here. So I would need to look at that next digit. My answer should just be 5.2 in that case. I do not round up on that. All right, next one. My parentheses first, I need to add those digits, and because I'm adding, I need to make sure that I record to the least number of decimal places. The 209.2 has 1 decimal place, and this one has 2. So I need to add these numbers and then make sure I get them to 1 decimal place. Well, when you add them, you get 368.03. Well, that's 2 decimal places, and I need 1. Well, I need to stop here. The 3 is not going to round it up. So I'm looking at using 368.0. So then I need to go on to my next step and say 368.0 divided by 3.50. Well, now I'm dividing. A different rule here. This one has 4 significant figures. This one has 3. So my answer needs to go to 3. But I just want to get the number first and then decide, okay, what am I going to do? This number should be 105.1428 is what your calculator gives you. But again, I'm looking at lowest number is 3 significant figures. That's these 3 right here, counting from the beginning, but that 1 is not going to round it up. So my answer should just be 105 for that one. All right, next one, parentheses first. I need to subtract those numbers. My calculator gives me 306.036. But again, I need to look. This one right here only has 2 decimal places. The number I've just written down has 3, so I need to round it correctly. So again, I need 2 decimal places, but what is that 6 going to do? That 6 is going to round it up, so it's going to have to be 306.04 what I go on with. So then I need to take the 306.04 and multiply it by the 45.4, my next step in the problem. And that gives me, my calculator gives me 13894.216. So clearly way too many significant figures, because if you take a look at this number right here has 5 significant figures. This number right here has 3. I need to somehow make my number have 3 significant figures. That's this right here. So what do? I have 2 options here. I can look at that next digit and say, well, that's going to have to round that up. So this would be a 1, 3, and a 9. You can't just stop there. You can't make 13,000 be 139. So those numbers that I rounded, those become zeros. So I would say 13,900. So I rounded 13,894 up to 13,900 to get 3 significant figures. That's one option. Other option, I'm going to kind of write it over here to the left. I could put this in scientific notation like I've learned to do. So I could move it 1, 2, 3, 4, and I would say 1.39 times 10 to the 4th, which is 13,900. So those are my 2 options. All right, I'm going to do my last problem in a different color just so it doesn't kind of bleed in with the other one. So this one's going to be done in blue. Okay, so 24.3 times 2.7. When I multiply that out, I get 65.61. Again, I got to look at my significant figures. 2.7 has 2 significant figures. So that means I'm going to have to stop right here, but that 6 is going to round that 5 up, and I'm going to be dealing with 66 now. So it's going to be 66 divided by 4.75. Now, if I hadn't rounded that 65.61 up, if you look at it now, this one is my lower number of significant figures. If I hadn't fixed that before I moved on, I would end up getting my wrong answer, and I might go with these 3 significant figures there. But my final answer needs to be 2 because of that 66. So when I divide these out, the number that I get is 13 point, that's a long one, 89473,684. So obviously not my answer. I can't just write down what I get in the calculator. I need to look at this and say, well, I need 2 significant figures. That would be these 2 right here. But I've got to take a look at that next number and say, well, that 8 is going to round that 3 up. So answer, 14. All right, so I probably don't need to go through this because I think I've pretty much covered it. But the whole rounding rules, you know, you have to make sure that you round a calculation to the correct number of significant figures. So you've got to make sure that you look at that next digit like I was showing you. So if I need 2 significant figures on this one, again, I'm stopping there and I'm not going to round that up because that next digit's a 4. That's why this stays 4.3. But in the next one, if I want to stop at 2 significant figures, that next digit is a 6. Some people try to look at even the digit after that. But again, it's just where do you want to stop? Look at that next digit. And because it was a 6, I would round it up to 4.4. Okay, so now you have all the information you need for significant figures. I need you to go and answer your concept review over significant figures and turn that in, and we will move on to dimensional analysis next.